All right, hi folks, this is Larry Maslino. I'm recording a video for Objective 1 in ALEX. So I wanted to do a few examples to help you get started in Objective 1. So if I scroll down a little bit here, all of these topics are part of the topics to be completed in Objective 1. And I want to do a few of these examples just to help you get started. Now, one comment is that one of the first things you're going to do in the course is take what's called the initial knowledge check. When you take the initial knowledge check, you might demonstrate to Alex that you know how to do some of these topics. So some of these topics might not be applicable to you, meaning Alex has taken these topics off of your pie. Now in Alex, you have a pie that's going to show you how many topics you've completed so far. And Alex might take some of these topics off your pie because you showed through the initial knowledge check that you've already mastered some of these topics. But I want to do a few examples just in case you are going to work on some of these. Let me come here. I'm going to do an example on rounding. So you might remember rounding, but let me just give you a quick reminder in case you're a little rusty. Now, one thing you're going to notice in ALEX is that whenever you start a topic, there's going to be an explanation. The explanation is going to show you step by step how to answer the question. Sometimes there's an alternate explanation. Notice here it says another explanation. So you can use whatever explanation makes more sense to you or helps you to successfully work through this example. All right, so let's do this example. It says round 167 to the nearest 100. All right, well, the way you do a rounding process is first, it's a good idea to circle the digit that you want to round. So when I think about digits, this is the ones position, this is the tens, and this is the hundreds. Okay. By the way, folks, in our course, there's what's called a reference packet. And a reference packet is a set of notes that you can use at any time. So if you're taking, if you're working in a topic, if you're taking what's called a knowledge check, you're free to use these notes, these reference packet, it's called, anytime you want. So let me just show you the reference packet so that we can keep it handy. I think I have it open. Yeah, here it is. So if you notice, let me scroll down a little bit. There is, yeah, right here. Can you see there's a place value chart? So this place value chart is showing you, here's the decimal point. So the digit to the left of the decimal point is the ones, then the tens, then the hundreds, and so on. So if you forget these place value indicators, you can use this place value chart as a reminder. All right, I'll come back to this reference packet because we can use this for other topics. All right, so let me go back to our example. All right, here it is. All right, so they're asking us to round to the nearest 100. So I think it's a good idea to circle the position they're asking me to round. So they want me to round this 1. Well, I have two choices. I can either round the 1 up, that would make the 1 get bumped up to a 2, or I can round down, which means leave the 1 as is. So how do I know whether to round up or to round down? Well, the key is you look over to the right 1 position. So you look over to the right 1 digit. If that digit to the right is a 5 or greater, that's when you round up. But if the digit to the right is a 4 or lower, that's when you round down. Well, in our example, the digit to the right is a 6. A 6 is 5 or greater, so that tells me to round up. So this 1 gets rounded up or bumped up to a 2, and then you make all the other digits going to the right zeros. So this answer is 200. All right, let me do another quick example like this. So I'm going to come over here to show another. If I want more practice, I can click here, show another. All right, let me do a different one. All right, let's do this one. It says round 72 to the nearest 10. Well, I know this is the ones position. This is the tens position. So they're asking me to round to the nearest 10. They want me to round this 7. To make my decision, I've got to look over to the right. And I'm seeing number 2. Well, if that number to the right is 4 or lower, you round down. But round down means leave the 7 as is and make all the digits to the right zeros. So this answer is going to be 70. Okay, and if you notice, this explanation here is telling you exactly how to do it, right? It says, first find the rounding place, which is the 7. Look over to the digit to the right, that's the 2. If this digit is less than 5, round down, which means leave it the same. But if that digit to the right is 5 or greater, then you bump up that rounding digit by 1. Okay, our example, the 2 is less than a 5. That means the 7 stays the same. So our answer is 70. All right, so that's an example on rounding. Let me go to another example. How about, let me do an example here. Order of operations. Let's do that. All right, so in this example, they're giving me an expression and they're asking me to evaluate it. Now, what I have to be careful about here is I've got to follow a very important step-by-step called order of operations. So let me go back to the reference packet and let me move this over here so I can put it side by side. All right, I'm going to come down to order of operations, which is, we find it, here it is. So notice order of operations are these 4 steps. The first step is work out any operations inside parentheses. Well, in our example, we don't have any parentheses. The second step is work out any exponents. Well, we don't have any exponents. The third step is work out any multiplications or divisions going from left to right. Now that's important that I go from left to right. All right, I'm going to go from left to right. As I go from left to right, the first thing I'm seeing is this multiplication. So I'm going to work that out. 3 times 8 is 24. I'm just going to write the rest of this expression down. All right, I'm going to keep going. I still have to look for any multiplications or divisions going from left to right. Well, if I do that, I'm seeing this division. I'm going to work on that next. 24 divided by 4 is 6. All right, now I'm left with addition subtractions. It says here, work from left to right. So I'm going in this direction. I see the addition first. 24 plus 6 is 30. And finally, I'll do the subtraction last. I get 27. It's very important that you follow these instructions very carefully. Let me give you a different example just to illustrate that. 10 plus 7, subtract 2. Actually, let me do a different example. Let me do 20 subtract 5 plus 7. All right. Well, should I do the addition first or should I do the subtraction first? It's important I know that because I'll get 2 different answers depending on if I do the addition first or the subtraction first. Sometimes students think, well, you should always do additions before subtractions. That's not true. That's not correct. The rule says work from left to right. So I'm going to go from left to right. Well, when I go from left to right, I'm actually seeing the subtraction first. So I have to work out the subtraction. 20 subtract 5 is 15. Then I'll work out the addition. All right, so you got to be careful to follow these order of operations steps very closely. All right, I'm going to go back to Alex. Let's do another example. But here's one, ordering integers. All right, so what this is going to ask me to do is in these blue boxes, I should either put a less than sign, a greater than sign, or an equals, or an equal symbol in the blue box. All right, now, one way to think about this is think of a number line. A number line is where we draw this line, we put 0 in the middle, we put the positive numbers going to the right, and the negative numbers going to the left like this. This makes it easy to compare numbers because the greater numbers are on the right-hand side and the lesser numbers are on the left-hand side. So let me do a comparison. -7 compared to -11. Well, if I was to draw a number line for that, -7 would be here and -11 would be over here. But notice this -7 is to the right of -11. If a number is to the right, it must be greater. So -7 is actually a greater number compared to -11. So I'm going to put a greater than symbol here. All right, let's do the second one, 8 and 9, comparing 8 and 9. Well, 8 is here, 9 is there. Notice 8 is to the left of 9. Well, if a number is to the left, it's a lesser number. So I'm going to put a less than symbol here. All right, let's do the last one, 0 compared to -2. Well, I'm noticing 0 is to the right of -2. But if a number is to the right, it's a greater number. So I'm going to put a greater than symbol here. So if you can draw a number line, it helps you visualize where these numbers are sitting on the number line, and it makes it much easier to compare the two numbers. If a number is to the right of another number, that number is greater. But if a number is to the left of another number, that number is lesser. All right. Let me do another example. How about combining like terms? All right. Folks, what we'd like to be able to do here is combine these expressions that have letters in them. We call the letters variables. And what we like to be able to do is add or subtract these variable terms where permitted. So let me give you a couple of examples before we do this example. First, we have to talk about something called like terms, because when you go to add these expressions, you can only add what are called like terms. So how do you know a like term when you see it? Well, a like terms have exactly the same letter part. Let me give you some examples. These are like terms. 7x and 2x. Notice the letters there are exactly the same, x and x. 5x to the 2, 3x to the 2. Again, those are like terms because the letter part is x to the 2, and it's identical. Let me give you some example of not like terms. How about 7x and 2y? Well, those are not like terms because the letter part is not the same. This is an x and this is a y. Well, that's different. How about 5x squared and 3x? Well, these are not like terms because, again, the letter part is not the same. This is an x to the 2. This is just an x. It's got to be exactly the same. It's got to be the same letter with the same exponent on it. Well, it turns out you can only add like terms together. Let's do a quick example. If I was going to add 7x plus 2x, the way you do it is you keep the letter part the same. So I have an x here as the letter part. I keep it as is. I just copy the x over. And then you add together the numbers in front. 7 plus 2 is 9. So adding 7x plus 2x gets us the result 9x. How about 5x to the 2 plus 3x to the 2? Well, you keep the x part the same. So I'm going to leave the x to the 2 as is. And then I'm going to add together the numbers in front, 5 plus 3. That gets me 9. All right, let me come back to the example they gave me. Well, they have negative 11c to the exponent 2 minus 3c to the exponent 2. These are like terms because I have a c to the 2 here and a c to the 2 there. They're exactly the same. Leave that as is. and add or subtract the numbers in front. Well, when I add or subtract these, this is going to be negative 11 subtract 3. Well, that's negative 14. So that's what I put in front, negative 14 c to the 2. All right, let me do another example maybe. All right, let's take a look here. All right, well, let me look at the like terms. Remember, like terms have to have the same letter part. Well, I'm seeing a negative 7x and a plus 7x. Well, the rule is you keep the letter part the same, that's x, and you add the numbers in front together. That means I'm going to add a negative 7 and a positive 7. But negative 7 and positive 7 is 0. Now, this plus 10, I'm just going to bring down with me. But 0 times x is 0 because 0 times any quantity always stays at 0. So this is going to be 0 plus 10, but 0 plus 10 is just 10. So the answer to this one is 10. All right. And folks, remember, if you're looking at these problems and you're stuck or you need some extra help, come here to explanation. If you come here to explanation, Alex will try to give you a step-by-step discussion. And notice they're showing here that negative 7x and positive 7x works out to be 0x. And 0x is 0. So the final answer here is just 10. All right, so please use these explanations. All right, let me go to another Alex topic here. How about distributive property? All right, it says use the distributive property to remove parentheses. Well, here's what the distributive property says. If you have a number, I'm going to give you a different example here. How about 5 out in front of parentheses like this? You can distribute this 5 by letting it multiply the first quantity and letting it multiply the second quantity. So in my example, 5 times x is 5x. I copy this plus sign down, and then 5 times y is 5y. So to distribute a number means take the number from in front of the parenthesis and let it multiply every quantity inside the parentheses. All right, well, in our example here, let me write the example they gave us, u plus 5 times 10. Now, they put the 10 in the back of the parenthesis like this. But if you want to, you're allowed to switch the order of multiplication. You know, if I have 7 times 2, that's 14. That's the same as 2 times 7. That's still 14. So anytime I have a multiplication, I'm allowed to switch around the order. I'm going to do that to make this a little easier. I'm going to take this 10 and put it in front of the parenthesis. I don't have to do that, but it just makes it a little easier to recognize the distributive property. Well, the distributive property says you could take this 10, let it multiply the u, so that's going to be 10 times u. Then I can let this 10 multiply the 5 in the back, so that's going to be 10 times 5. But 10 times 5 is 50, so I can write the final answer like this. 10u plus 50. Notice I can't combine 10u and 50. These are not like terms. So that's why I have to just leave 10u plus 50 as is. I cannot simplify it any further. All right. Let me go and do another Alex. Let's do this one. All right, so this one is asking us to use the distributive property and combine like terms. Let's do an example here. This one's a good representative example. All right, what they're asking me here to do is to simplify this expression. Well, when they say simplify, what they're really asking you to do is get rid of the parentheses. And I can do that by using the distributive property that we just talked about. And then they're also going to ask me to combine like terms if possible. All right, so let's do the first step. I'm going to take this 5 and let it multiply inside the parentheses. Now I'm going to write it out. I'm going to write as 5 multiplying 2y minus 5 multiplying 3. All right, I'm going to do the same thing in the back parenthesis because this 4 multiplies that 4y. And then finally, this 4 multiplies that 4 in the back. All right, well, let me do all these multiplications because I have 5 times 2, that's 10y. 5 times 3 is 15. 4 times 4 is 16, so that's 16y. And back here, I have 4 times 4, that's 16. All right, well now, so we just did step 1. Let's go to step 2, combine like terms. Remember, to combine terms, you have to have the exact same letter part. Well, I'm noticing here's a y, and here's another y. So these are like terms. I can combine them together. The rule is you keep the letter part as is, that's the y, and add together the numbers in front. Well, 10 plus 16 is 26. And then I have 26y minus 15 plus 16. Well, of course, I can add these numbers together, right? These are just numbers, so I can add them together. I can think of this as negative 15 plus 16. That's a positive 1. So I end up with the final answer, 26y plus 1. Again, I can't combine these terms because they're unlike terms. All right, remember, folks, you could use the explanation here if you needed some extra help. All right, folks, please let me know if you have any questions. Hopefully this helps you to get started here in Objective